Hey everyone, so we are now we're continuing with graphing polynomials, but we're going to deal with something called multiplicity. All right, I would like you to factor completely. I'll give you a hint. There's a GCF and then an MC chart. So what is the GCF? Pause and do it. So our GCF is x squared. When we divide, we get x squared plus 8x minus 9. That's an MC chart, right? Multiply to negative 9. Multiply to negative 9, combine to positive 8. 1 and 9 with the 1 negative. X minus 1, x plus 9, and then that's not our final answer. What's the final answer? GCF on the outside. That is our answer. Okay, so do a quick review for number 1. Number 2 is a little different, so see if you can figure out what number 2 looks like. All right, so our zeros, our roots are 0, negative 2, and 5. So we have, if we plug in positives, and we have that negative in front, and then a positive, a positive, a positive, that gives us a negative. So on the right, we're going down. And then if I plug negatives in, that negative out front is this one. And then x plus 2, x minus 5. So if you notice, we have 4, so that means that's a plus. It's going up. And then I just go through the graph, up and over. That's it. Okay, so this one, we haven't graphed anything like this. So whenever you're stuck, just make a table. So I'm going to do negative 2, negative 1, 0, 1, 2. What is 2 to the third? 2 times 2 times 2. That is 8. 1 to the third is 1, 0. Negative 1 to the third is negative 1, right? Negative 1, negative 1, negative 1. And negative 2 to the third is negative 8. So 1, 2, 1, 2, and then we'll make this negative 8. And this 8. So when I graph this, I've got negative 2, negative 8, so down here. And then, negative 1, 1, 0, 0, 1, 1, 2, 8. So here's what this looks like. So this is the parent function, x cubed. Notice it looks a lot different than this guy. So the parent function, unlike a parabola, looks a lot different than an x cubed. Like if this is an x cubed problem. If you multiplied it out, it would be negative x cubed plus a bunch of stuff, right? So the parent function does look a lot different. Okay, so now I have the parent function plus 2. So what do you think that does? So we're just going to go up 2, right? So 0, 0, and then 1 cubed is 1, negative 1 cubed is negative 1, so over 1 up 1, over 1 down 1, over 2. So it's just that same graph, we just shifted it up 2. Right? And again, you can just make a table, x, y, negative 2, negative 1, 0, 1, 2. 0 is 2. 1 is 3. We're just plugging in. That's a 1. Let's see. Negative 8, negative 6, and 10. Right. So I just made it. You can just fill in the table. All right, number 4. Graph it on your own. So 0, 0, right? Negative 2, negative 1, 0, 1, 2. What does this guy look like? Now, basically, it's the same thing, but all the signs are switched, right? Because if you plug in negative, negative 2 to the third, that's negative, negative 8, which is 8. So it's the same graph, it's just flipped. So we got that and that. And that's it. So that's the parent function. All right, so we know how to graph the first 3, so graph those. What does y equals x look like? What does x squared look like? What does x cubed look like? So pause and do those. That's a terrible picture. x is just a line. X squared is just a parabola. X cubed is what we just talked about. So I call this, it's got what's called an inflection point. So that little flex at 0, 0 is called an inflection point. What do you think x to the fourth is going to look like? So 0, 1 to the fourth is 1, 1 to the fourth is 1. What's 2 to the fourth? 2 to the fourth is 16, so it's 2 comma 16. So x to the fourth is just a skinnier parabola. How about x to the fifth? So again, 0, 0, 1, 1, 1, negative 1. 2 to the fifth is 32, so it's like way up here. And then negative 2 to the fifth is down here. So x to the fifth is just a skinnier version of x cubed. So what do you think for x to the sixth? That's just an even skinnier parabola, right? So when you're looking at the parent functions, anytime it's even, it looks like a parabola. Anytime it's odd, it looks like that x cubed. It just could be skinnier. And then a line is a line, right? It just goes through nice and smoothly. Okay, so we are going to graph this. So think about what the roots are. What are the roots here? We got -2 and +5, right? So -2 and +5. All right, so those are my roots. But now this one's weird because of that squared. So what I want you to do is plug in, why did I do -5, -2? Let's make this a -1. All right, I want you to find the y value. So grab your calculator and plug in. What do you get? All right, so I got -90, -6, -20, and 162. All right. So -5 is over here. So -5, -90. So it's like way down here. And then -1 is -6. So like here. 0 is -20. And 7 over here is 162. So like up here. So now if I connect these, right? So this connects up to the -2, right? And then it comes down. And then I have to come around to that 5. So it comes down and around and then up. That is what this thing looks like, right? If we think about the end behavior, right, as x goes to infinity, we get infinity, right? A plus and then a plus squared, right? As x goes to negative infinity, we have a negative times a negative squared. I mean to make -1 just negative. So we get a negative, right? So it's on the left, it's going down. On the right, it's going up. But now what happened at -2? What does that look like? Instead of going through the graph, it hit it and came back. So it kind of bounced off the axes. Why do you think that happened? What's happening in the equation with the -2? It's got a squared. You notice that kind of looks like a tiny parabola. It's not actually a parabola, but it kind of looks like it, right? It hit the graph and came off. So it's a downward facing parabola. All right, same idea. I want you to plug in, find your y values, and then try to sketch this. So my roots are -8, 12, and 4. So we know that. So -8. 4 would be like there, and 12. All right, so let's plug in and see what we get. Okay, so now when I plugged in for 10, I got -1.2 e to the 5. That's negative 1.2 times 10 to the 5th. So that's a really big negative number. That's like almost a million, right? 0, I got 6144. For 2, I get 800. And 14, I got 4400. So this one's a little crazy. Right? All right, so negative 10 is over here. It's down negative. 0 is 6,000. So let's make that there. 2 is 800. I messed this one up again. I don't know why I put 2. It should have been like 6. Let's erase this. Let's find 6 instead. I need a number between the 4 and the 12. All right, 6 gives me negative 672. So we're down here. So like there. And then 12, and then 14 is up high again. All right, so we're going to connect all these dots. So I'm starting here. So I got to connect the negative 8. And then it's got to go up and connect to 0. Comes down to the 4. Comes down. And then... Okay, so now this actually is not right. What do you think is supposed to happen at... We have an extra exponent, right? There. So in the last one, we had a parabola. So let's look at that. Grab your graphing calculator. Take a look at this. What is happening? At this minus 4, instead of just going in right smoothly, what happens is it's got that little inflection point. It's going to look like the parent function, right? Remember, the parent function of an x cubed looks like this. So at 4, we get this inflection point, and so we're going to kind of flatten it out and then go up, right? So anytime you have an exponent at that root, something weird is going to go on. So a multiplicity is the number of times a particular number is a root or a 0. The sum of the multiplicities should equal the degree. So this has a root of 0. It's a double root. It's got a multiplicity of 2. At 0, 0, it's going to have a little parabola, either upward facing or downward facing. We have no way of knowing which. Right? To the 4th, so at negative 6, we have a multiplicity of 4. So a multiplicity of 4, it's going to be either a skinny parabola, either up or down. X equals 2 is just a regular multiplicity of 1. So it goes through the graph like normal. And then at x equals 9, we have a multiplicity of 5. That's going to be a skinny x cubed. So it's either going to look like this or like this. And the thing is, we don't know what which direction. We can't tell from the signs. We're going to use our end behavior to figure that out. Okay. What happens to a graph if a root has a multiplicity of 2? So at that root, there is a tiny parabola. We don't know if it is upward or downward. Again, it's not, I put parabola in quotes because it's not actually a parabola. It just kind of looks like a parabola near that 0. And then if we have, and that's also true for any other even root, right? Anytime you have an even root, you're going to have something that looks like a parabola. And then if the multiplicity is 3 or it's odd, it's going to have something that looks like an inflection point, right? So if I have, right, if this is my multiplicity, I'm going to have that, and then just come around and go through. Right? So you're going to have that weird inflection point at that root. Okay, so now we're going to do this the same way we did before. So start with our zeros. So 0, negative 8, and negative 1. Right? My y-intercept is 0, 0. As x goes to infinity, what happens to my y? Right? So I plug in negative a positive squared times a positive times a positive. What that gives me a negative. So we're going to be going down on the right when x goes to negative infinity. So we've got that negative in front, and then negative squared, a negative, a negative. So that gives me a negative. So we're also going down. So I've got 0, -8, and -1. All right, so on both sides we're going down. So at -8 we're going down, at 0 I'm going down, right? Now, where do we have a multiplicity? We have a multiplicity at 0. So on this right side where the 0 is, instead of this going through the graph, I know it's going to come back down. So I'm going to draw it coming, it's going to come down a little bit, right? 8 doesn't have a multiplicity, so it's just going to go through the graph. It's going to come down, hit -1. -1 is going to go through the graph, and then it's going to connect, and we're going to kind of, it's really little. Let me fix this. So it's going to come down like this. So at 0, 0, right, at just around that point, we've got that little downward facing parabola. Now, it is not down because there's a negative in front. It really depends on the problem. We can't tell until we do our end behavior. So at 0, 0, it hits the axis and then comes off. So that is our graph. All right, I want you to pause and see if you can try this one on your own. So my zeros are 0, -8, and 5. So now we have two multiplicities. 0, 0, right? If I plug in 0 everywhere, x goes to infinity. X goes to negative infinity. All right, so if I plug in positives, a positive to the third, a positive squared. So that's a plus. So we're going up on the right, and then a negative to the third, a negative squared. Let's see, that's 2, that's positive, and then we've got 4 negatives, so that's a plus also. So they're both going up. So I got -8 and 5. All right, so they're both going up. So 5 is going up, and 8 is going up. But now, we have a multiplicity at 5. What's happening at 5? It's got a square, so instead of going through the graph, it's going to come back up. What's happening at 8? 8 has that inflection point. It's to the third. So I'm going to actually erase this, and I'm going to try to draw that inflection point in. I got to start up, and it comes kind of down like that. So then we're just going to come down and around to get to the 0. 0 goes through nice and smoothly, up and over. And that's our graph. I know a lot of you have trouble drawing the inflection point. On a quiz, what kids just do is they'll write a little like arrow, like that's an inflection point, just to let me know in case they messed it up. Okay, last one. Pause and try it on your own. So we've got our roots of 0, -5, and +10. Again, y-intercept is 0, 0. X goes to infinity, x goes to negative infinity. Let's see what happens here. So I've got that negative x squared, so negative squared squared, so plus plus plus. So that negative gives us a negative, so we're going down. And then the negative, something squared, something squared. So we've got minus, minus, minus. So this gives me a plus because it's squared. This gives me a plus because it's squared. And then we're left with two negatives, so that whole thing is a negative. So we've got 10, -5, and 0. So end behavior, we're going down on the left. up on the right. And then at 10, we don't have anything weird going on, so it's going to go through nice and smoothly. At -5, what do we have? We're going to have a parabola because it's squared, so it's going to come down, back up. And then we're going to go down and hit 0. And what happens at 0? That also has a square, and so that also comes up. And so make sure, here's what happens. Kids get confused, and this is what I see a lot of. So they get confused and they'll do like that. Once you graph, check, are your roots correct? Because in this case, you just magically added an extra root. You can't just like go through the x-axis again for fun. That's not allowed. So that's kind of a telltale sign that you mess something up, is if you have an extra root somehow. So definitely check that you don't add an extra root into the problem. Right? So I got 2 little parabola guys. So notice this time it's negative out front, but it's upward facing. So again, the negatives in the problem, you don't know which way it's going to hit and come off if the little tiny fake parabola is up or down. We have no way of knowing that. We use our end behavior and our multiplicity rule. All right, and that is it. Have a great day.